Hello students, today we will go for integration. Last video we have completed a little bit of differentiation, and so next part is what? Integration. Now first point, what is meant by integration? Why we do integration in physics or in mathematics, right? It is vast big subject, okay? So for first years we need very small part of integration. So that today I will going to cover. Now you need to understand what is integration. First point, integration means it is very simple. It is process of adding the values. What kind of values? Very small values, infinitesimally small values. We are going to add them. Now if it is process of adding, then why we should not take addition? Simply we can add, no? This is our addition. Simply we can add the points or quantities, right? Just like 1 plus 1, 2 plus 2. Okay, just like that. We can add now. Why we should go for integration? So that we will see now. Now see, addition we do in case of finite quantities. Now what is finite quantities? Just small numbers, okay? 5 plus 5 like that. Now next comes summation. After our addition, we know one more process called summation. I hope you know this summation. Now when we use summation, finite quantities but large number, in large number, okay, adding series of values, then we go for summation. Okay, first step is what? We go for addition for finite quantities. Next we have summation, right? For finite more number of large number of quantities, we go for this particular summation. Now next comes integration. Now what is the sign of integration? This is sign of addition, this is sign of summation. Integration, it is written as like this, extended S, okay, S we write like this now. If you extend it, that becomes integration. Now what is the work? Why we use integration if it is similar to addition or summation? So this is different tool, little bit different tool. How it is different? Now using integration, you can add very small quantities, okay, and those small quantities are infinite in number, right? In this case finite numbers, here also we have finite numbers, but here infinite number, and each quantity is what? Infinitesimally small, very small quantity. If they are very big in number, very big means infinite numbers, and each number is what? Very small, and then you need to add them. Then what we do? We go for integration. This is the use of integration, okay? So today's class we will deal with this particular process called integration. Now see, whenever we say integration, there is a definition, because see, already we have studied differentiation, no? So now we will try to link this differentiation with integration. Now how to do that? General definition, always we write this, integration is the reverse process of differentiation. Okay, so this is very clear already, means those who don't know, please, okay, go through this. What is this? Integration is the reverse process of differentiation. Now first point, we know what is differentiation. So today's class will be like, I will compare these two things. If this is reverse process, we will know what is, first we will know what is differentiation, then using that we will see integration. Means it is like comparing these two things, then it will be very easy. And I will not cover everything here, okay, because this is very big subject, okay. So we will see only small part which is useful in first year physics or in second year physics, okay. So now this particular definition you should remember, okay. Once you get this definition, it is very easy to understand integration, okay. Now for this, first step what I will do is, from last class we have completed PT graph, okay. Now using PT graph, that is like this, P, T, this is y-axis, this is x-axis, here we have origin. So this is our PT graph. Now here we have line, straight line. As we know, this particular straight line indicates, what it indicates? Uniform motion, uniform motion. Now using this particular graph, see here I am explaining differentiation. Why? Once you get differentiation, its reverse process is what? Integration. Already this is completed. So now if I want velocity from PT graph, then what I do? I go for slope. Okay. Now see, like this, slope. Already we have completed this, ABC, right? Slope equals to AB by BC, right? Tan theta, same concept. This equals to what? Velocity. So now one property is there. What is that property? For PT graph, we have one property. Slope of PT graph gives velocity. Slope of position time graph gives velocity. Right? Very clear. Now, our next step is what? If this is true, now we can write V equals to what? Dx by dt. From differentiation, we know this. Rate of change of position with respect to time gives you velocity. Simple concept. This is very important. As we know, integration is what? Reverse process of differentiation. Let's see using VT graph. Let's draw VT graph for this particular PT graph. So here I will write V and here I will write time 0. Okay. Now for this particular PT graph, how to write VT graph? Now this indicates uniform motion, or we can say constant velocity graph. Constant velocity graph means simply you can draw the line, horizontal line, and it is parallel to what? Time axis or x axis. This is x, this is y. We know one more property from first chapter.
Actually, it is from third chapter.
What is that property? Property of VT graph. What is that property? Area under VT graph, it gives displacement. Area under this particular VT graph. So now to get area under this curve, what we do? We write dashed line like this. So here find the area of this particular rectangle. Now area of this rectangle A is equals to what? Quantity displacement. Okay, this quantity is equals to what? Displacement. Now, area of this VT graph is what? Displacement. Now try to look at the process here. Here we have VT graph. Its slope gives what? Its slope gives velocity. Next we have VT graph. Its area gives displacement. Therefore, this is graphical method. This is graphical method. Take PT graph, get its slope, it is velocity. Take VT graph, find out its area, it gives displacement. So they are kind of what? Reverse processes like this. Getting the slope gives you velocity. Take another VT graph, find out its area, it gives displacement. Okay, means this is one particular process. If you take this as differentiation, then this is integration, because differentiation gives velocity and integration of that velocity gives you displacement. So it is called reverse process, differentiation and integration. Integration is what? Reverse process of differentiation. So now mathematically how to do that? So now for V you need to have the equation. Okay, for V you need to have the equation. Take that equation and differentiate. Take that equation and integrate that. Now for example, here using this we can write dx equals to, cross multiply and write dx equals what? V dt. So now you integrate this equation, you will get displacement. So now from graph what we can say? Area under VT graph is what? Displacement. This is graphical method. Slope of PT graph is velocity, area of VT graph is displacement. So this is kind of reverse process. This is using graph. Now using integration, how to get that area? Area is equal to displacement, remember this. Next step, I will take one more example. So for example, here I have AT graph. What is AT graph? Acceleration time graph. Here I will draw the line. What it indicates? Constant acceleration. So if you find out area under AT graph, that gives velocity. Okay, so using this, if you have equation for acceleration, okay, using that equation or function, you can find out velocity. So slowly we can come back also. So in case of differentiation, it was like this: displacement, differentiate it, okay, differentiate it, displacement, differentiate it, you get velocity, differentiate velocity, you get acceleration. Now in case of integration, we have reverse process. I have acceleration, right? Integrate acceleration, what do you get? Velocity. Integrate velocity, what do you get? Displacement. So this is reverse process. You need to understand this. Once you get this particular concept, it is very easy to integrate. Okay. Many of our students, they don't know the actual physical meaning of integration and differentiation. So I hope this will help you. Now what? We need to know some formulae. Okay. That's it. For first year, some formulae are there. Some formulae they have mentioned. We will go through them. We will perform some problems. We will solve some problems. Then we will take one particular equation for velocity as well as acceleration. Next part is what? We will try to get their values, area values, and that will be like, if you integrate velocity you get displacement, if you integrate acceleration you get velocity. We will see that process also. So in the next part we will see what? Some formulae. So these are some formulae. Here we have two types, indefinite integral and definite integral. So let's see what is indefinite integral, and there are 5 formulae I have written, and these are important formulae. Now x raised to n dx, integration of x raised to n dx, it can be written as x raised to n plus 1 divided by n plus 1. This is first formula and it is very important. Next we have x raised 1 by x, integration of 1 by x dx, it is log x. I think you may remember from differentiation. Differentiation of log x is 1 by x. So here we have same concept. Reverse process. Integration of 1 by x is what? Log x. Now third one is integration of sin x dx. It is minus cos x. So those who remember, again formula from differentiation, it is very easy. Differentiation of cos x, it was minus sin x. So here integration of sin x is what? Minus cos x. Next step, cos x dx, integration of cos x dx, it is sin x. Fifth one, integration of e raised to x dx, it is e raised to x. Again it is very easy. Why? Differentiation of e raised to x is what? E raised to x only. So integration of e raised to x is what? E raised to x only. Reverse process. You should get same answer. Then here we have definite integral. Definite integral. In definite integral, here you can see one difference. What is that? Compared to this one and this one. Here we have limits, values are given. This is called lower limit, it is called upper limit. Lower limit is what? A, upper limit is B. And these A and B, they are just numbers, okay, boundary for integration. So here we have f of x and dx. So what is f of x? Any function. It may be x square, it may be sin x, it may be 1 by x, anything, one value or function. Next, after integration, you get the answer. For x raised to n, if it is x raised to n, you get answer x raised to n plus 1 by n plus 1. Here, that is written as g of x, another function, another value. Next, you need to put the square bracket, put the upper limit and lower limit, and apply the upper limit and lower limit. How to apply them? See, g in place of x, write b, minus g in place of x, write a. So it is called, it is g of b minus g of a. This is how we put the limits. This is called definite integrals. Now we will take some examples and then you will come to know what is the difference between indefinite and definite. So let's take one example. First one, we will begin with x square. Okay, so x square we need to integrate. Integration of x square, while integrating you need to write dx. X square dx, integration, use the formula, in place of n, 2 is there. So x raised to 2 plus 1, it is like n plus 1 divided by n plus 1, 2 plus 1. Okay, so that equals to x raised to 3 plus 3. Along with this we write plus c. So why we should write 3? sorry, why we should write c here, that I will explain in the next part where we go for physical examples. Now this is what constant, c means constant. Now when to use this constant, when to write plus c, whenever you integrate indefinite integral. Whenever you go for indefinite integrals, means whenever you don't have the lower limit or upper limit, in that case, okay, if you don't have lower limit and upper limit, in that case you need to write plus c. Next example, this is first one. Second example, root x dx. Integrate this one. So it is integration, I will write root as 1 by 2 raised to 1 by 2 dx. Next step, same formula, n plus 1, x raised to n plus 1, half plus 1 divided by half 1 plus, okay, 1 by 2 plus 1, that equals to x raised to 3 by 2 divided by 3 by 2 plus c. You can write plus c. You should write. Why? Because it is indefinite. This is second example. Let's see third example. So these examples, they are very useful while solving numerical problems. Third one, it is integration of 5x raised to 3 dx. So now here we have one trick. Whenever you find constant number, in case of integration, take it outside the integration, just like this. 5 outside the integration, then write remaining points. Now integrate x raised to 3. 5 as it is, x raised to 3 plus 1 divided by 3 plus 1 plus c will be there. Now finally it is 5 x raised to 4 divided by 4 plus c. This is your answer. This is your answer, integration answer. Now we will take one more, last one, simple example. It is fourth one. Fourth example is integration of 2x dx. Integration of 2x dx. But using the limit, we will consider limit. So instead of a, I will write 1. Instead of b, I will write 2. This is one simple example. Let's try. Now, as we know, take 2 outside. Take 2 outside because it is constant. Just now we have seen. Then write limit as it is 1 to 2. X dx. Apply the formula. 2. X dx integration is what? X raised to 1 plus 1, because power is 1. 1 plus 1 divided by 1 plus 1. Same thing here, n plus 1 is there, no? In place of n, here we have 1. Next, apply the limits. Here we have 1, here we have 2. Lower limit, upper limit. So 2 as it is x raised to 2 by 2, upper limit, lower limit. Now apply the limit. First we will apply upper limit in bracket. How to apply? Write this 2 in place of x. So it is 2 square divided by 2 over minus. Now apply lower limit. In place of x, write 1. So it is 1 square by 2. Clear? This is how we apply the limit. 2. Next, 2 square is 4. 4 by 2 is 2. Minus 1 square is 1 by 1 square is 1 divided by 2 means 1 by 2. So this is finally 2 into 2 minus 1 by 2 means 3 by 2. So the answer is 3. So now when you get the limits, upper limit and lower limit, you will get definite value, final answer. So no need to write plus c in this case, because we know from where to where we need to integrate. Means from where to where we are adding the values that we know. So no need to write c in this case. Now finally we will see one special example. Now what is that special example? I think it is fifth one. Integration of number. Let's take 7. How to integrate 7? For that you need to write dx again. Now as I told you, while integrating, take 7 outside because it is constant. differentiate dx. So how to differentiate dx? It is very simple. So now trick is there, simple trick. You can, already we know differentiation and integration, they are reverse process. So differentiation, it is cancelled with integration. Simply x will come. That's how you can remember, but that is not the way. How to do it then? 7 will remain out. Integration dx into dx. Now we can write 1 into dx now. Simply dx can be written as 1 into dx. And 1 I can write it as, instead of writing 1, I can write it as x raised to 0, because x raised to 0 is also 1. Then we write dx here. Next step 7. Now x raised to 0, use this formula. That is x raised to 0 plus 1 divided by 0 plus 1. So final answer is what? 7. X raised to 0 plus 1 means 1. 0 divided by 0 plus 1 means 1. So it is 1 and 1. So this is simply 7x. Please remember this particular integration. Correct. Okay, please remember this. Now it is indefinite, so you need to write plus c. So here if you get some value like 1 to 2, 1 to 3, something like that, then put the value of 1 upper limit and lower limit in place of x. That is also possible in case of definite integrals. Now homework, I will give you homework. So first homework, integrate x raised to 7 dx. Try this one. Second one, integrate x raised to minus 2 dx. Third one, integrate 7x square. Fourth one, integrate with the limit 2 to 4. Here I will write 3x raised to 3. Okay, for each we need to write dx. So these are some homework problems. So here we have 3 indefinite integrals and then last one is definite. Now if you solve these homework problems, integration will be very clear to you. Now in next part what we will deal is, we will take physical examples like velocity equation, okay, and acceleration equation. We will try to integrate them and then we will see whether we get displacement or not. See, when you integrate velocity equation, you should get displacement equation, position equation, and when you integrate acceleration, you should get velocity equation. So in next slide we will do that. For that, I will rub this. Okay, now see, for example, we know it is reverse process, integration, right? Integration is what? Reverse process of differentiation. So to justify that, what we do is, we will write one equation. For position. Then we will differentiate it. We will get one equation for velocity. We will take that velocity equation and we will try to integrate that equation. Now when you integrate that equation of velocity, you should get what? Same equation, that is displacement equation. Now v can be written as what? Dx by dt. So dx is what? V dt. This is clear, cross multiplication. Next step, we will write one example, no? X of t, that is t square. We will take one example, t square plus 2t plus 3, something like this. If you differentiate this, you get dx by dt differentiation, that is 2t plus 2, correct? Dx by dt means what? V equals what? 2t plus 2. So this is our equation of velocity. Now if you integrate this v, okay, we will see how to integrate. If you integrate this v, you should get this equation. Integrate these equations. You should get this particular equation finally. So what we will do, here we have velocity equation, we will integrate velocity equation. Okay, so here integration of dx is what? Remember this, integration of dx is x. Integration of dx means it is 1 into dx. You can think like this, right? 1 into dx. So 1 means I can write it as integration of x raised to 0, because x raised to 0 means 1. So we can do this. So next, use the formula. What is that formula? X raised to n plus 1, that is 0 plus 1, divided by 0 plus 1. So answer is what? 0 plus 1 is 1. X raised to 1 means x, divided by 1. And final answer is what? X. So now integration of dx means you need to remember it is x. Very simple. So because of this, here integration of x is what? Sorry, dx is what? X. So what about this side? Now v is there. It is there already. Let's integrate. Integration of v. V is equals to what? 2t plus 2. Clear? This is v. Then you need to write this dt from this particular arrangement. Dt will be there always. Without this, we cannot integrate. Remember. So x equals to, finally we should get this one, okay? Integration. Now there are two terms. Separately you can integrate like this. Integration of 2t, first term, okay? dt, multiply this inside. This is the way of integrating the term. Now integrate 2. Correct? This is the way. Next step. Now 2t integration is what? Let's do it. 2 outside, integrate t with respect t dt, plus here 2 is constant, take it outside. What remains? dt. Okay? Beautiful, no? You'll get to know final answer. Once you get the answer now, it is very beautiful. See, x equals to 2 is there already. Integration of t into dt, it is t raised to what? Here we have 1. So 1 plus 1. N plus x raised to n plus 1 divided by n plus 1. After integration, don't write dt. Remember this. Plus here integration 2 is there already, no problem. Integration of dt. Integration of dt, it is same as what? Integration of dx. Integration of dx is x. It means integration of dt is what? T. Simply it is t. Okay? And it is indefinite integration because we don't have limit here. So you should write plus c. Next step. This is 2. Then t raised to what? 2. 1 plus 1 2. Here 1 plus 1 2. Here we have 2t plus c. You can cancel this. So finally we have x equals to, or x of t equals to t square plus 2t plus c. So this is our equation. So now if you integrate velocity, finally we got displacement. So here we have equation. So you can compare this equation and this equation. You can compare them. So here we have t square, here also we have t square, here we have 2t, here also we have 2t, here we have c, but here we have 3. So now this is the problem of what? Our integration, if it is indefinite. Here we have 3, here we have c. We don't know what is that quantity, we don't get that usually if you follow integration. So we write one c here, if it is indefinite integration. So I hope you got this particular concept of what? Differentiation and integration. They are reverse process. Okay. So now take this equation, differentiate, you will get velocity. Take this velocity, integrate this, you get same equation. So this is called reverse process. Better we take one example, last example, then I will give you the homework, simple homework. So second example is v equals to 10t plus 3. This is the example. So now you need to integrate this. If you integrate this, you get what? Displacement. So let's do it now. Integration of this 10t plus 3. Okay. So now this is same as integration v dt. You need to write this dt. That equals to integration 10t plus 3. Clear? See how to write integration. You need to write dt here. Here we have t, no, variable term. Next step. This is known value. V dt integration is what? X. Already we know this. That equals to integration of 10t separately. Okay, here also we should write dt. So multiply this. Now integration of second term, integration of 3 dt. Multiply dt inside and then integrate. Next step, integration of 10t. 10 take it outside, constant, no? So t dt plus 3 is constant, again take it outside, integration of dt only. Next step, t integration is what? 10 as it is t 1 plus 1 t square divided by 2 plus 3 integration of dt is what? T. Finally you need to write c also, indefinite integral. Next, 10 by 2 means 5 t square plus 3t plus c. This is your displacement. So using velocity, if you integrate velocity, you get finally displacement. Now similarly, if you integrate acceleration equation, you get velocity also. Okay, let's see that one. I hope this is clear. Write down. So now we have velocity. Try to differentiate velocity. Differentiation of velocity is what? dv by dt. So it will help you. Okay, differentiation of velocity is what? Differentiation d by dt of 10t. Don't get confused. Okay, we are doing it at a time. D by dt 3. So this is 10 outside, d by dt of t, and differentiation of constant is what? 0. So here we are trying to obtain one equation. So dv by dt, finally it is what? 10 differentiation of t with respect to t is what? 1. So it is 1 plus 0 plus 0. So dv by dt means what? Acceleration a. Answer is how much? 10. So this is your answer, meter per second square. So this is your answer, acceleration. So if you integrate acceleration, you should get velocity, this one. Let's see whether it is possible. A dt integration is equals to 10 dt. That's how we write. Okay, if you want to integrate a, then you should write dt here. Next, integration of a gives velocity. Reverse process, no? In the beginning I told you using arrow mark. So this is v. This side 10 is constant, take it outside, dt integration. So 10 as it is, dt integration is t plus c because it is indefinite. So compare the equations. Here we have v equals to 10t plus c. Here we have 10t plus 3. There is a difference. We know here it is 3, but using integration we don't get it. So we write what? One constant every time if it is indefinite integral. So that's how it works. I will give one homework problem. You can try. So homework problem is v equals to 5t plus 7. Second one, not one, I will give two homework problems. Acceleration equals to 8, simply 8. Try this one. Very simple examples I have given. Now finally I will take one definite integral for velocity with limits. Integration from 1 to 2, simple example, and here I have velocity equation as 2t plus 3. This is our simple equation. So integrate this and put the limits. We will do it. That equals to integration 1 to 2, first one. So here I missed again dt. Please don't do that. Every time you should write dt. So this is what? Integration of 2t first into dt. Multiply this to each term plus 1 to 2 3 dt. let's do it fast. Okay, 2, it is common, not common, constant, take it outside. 1 to 2 t dt plus 1 to 2, 3 is again constant, take it outside, and dt. So next step, 2 as it is, integration of t dt is what? T square by 2, put the bracket, write the upper limit and lower limit, plus 3 as it is, integration of dt is what? T. So put the box, square bracket, then write the limit. Correct? Now here you need to apply the limits. 2, it will remain outside. First step, apply upper limit in place of t. So 2 is there, 2 square divided by 2. Correct? In place of t, write upper limit. Minus, in place of t, write 1. So 1 square by 2 as it is. Plus 3 as it is. Now in place of t, write 2. Minus, in place of t, write 1. Upper limit minus lower limit. This is the formula. And finally what? 2. This side what we have? Integration. Okay. 2, it is 4 by 2 means, this is 2 square is 4. 4 by 2 means 2, minus 1 square means 1 by 2, that is 1 by 2 itself, plus 3, in bracket we have 2 minus 1, it is 1. So finally 2 minus half means 3 by 2, I think it is 3 by 2, plus 3, correct. So here you can cancel 2, and what remains? 3 plus 3, that equals to 6. This is your answer with definite integrals. That's how you put the limits. Now third homework I will give, third one. So in that third homework we will use what? Limits. Okay, integrate from better you take 2 to 4. Do it. The equation is 3t square plus 6. Okay, find the answer for this one. This one, they are indefinite. This is definite. So this is from today's class. Try these problems. Again, for any doubts, comment below and we will bring you the new video. Okay, thank you.